Welcome to DrupalBrief. This is an AI-generated summary of another video, podcast, or blog post. If you want to learn more about what's being discussed here, then please go check out the source. This podcast is sponsored by Drupal Forge. Drupal Forge is an open-source, lightning-fast demo, development, and testing platform. It spins up Drupal sites in less than 5 seconds, complete with a browser-based VS Code. Want to try Drupal CMS, Drupal AI, Experience Builder? No need to install anything on your laptop. Drupal Forge has you covered. Even Composer, Drush, and AI keys are pre-installed so you can hit the ground running. Demo Drupal in less than 5 seconds only at Drupal Forge. Please take a second to click subscribe. We're a new podcast and this helps us a lot. Okay, that's it. Ready? Here we go.
Welcome to the deep dive. You know, AI is everywhere, right? Lots of buzz, loads of potential, but let's be honest, for a lot of us, it still feels a bit like this powerful black box. You hear about what it can do, but figuring out how it actually works underneath, especially with your sensitive data. That's often where things get fuzzy. So, our mission today, we're going to pull back that curtain for you. We're doing a deep dive into a specific AI setup. It's open source, it's global, and crucially, it's built privacy first. We've looked at the tech docs, the research, the notes to show you exactly how it's put together and run, really focusing on protecting your data by design. If you want that knowledge fast and clear, you're in the right place.
Yeah, what's really interesting here, I think, is we're digging into the foundations, the actual infrastructure. And the key thing is how this system manages to combine open source ideas with really strict, like enterprise-grade privacy. You often think of those as kind of opposites, right? But we'll see how they actually make them work together, especially when keeping data safe is the absolute top priority.
Okay, so let's start right there. What was the big push behind building something like this? I mean, this robust, privacy-focused AI infrastructure. Our sources point pretty clearly to strict data residency laws. Think about companies, say, in Switzerland. Legally, their data has to stay in Switzerland. Full stop. Cannot leave the country. And that's not just some quirky European thing anymore. It's really picking up steam globally. More and more countries are saying, nope, data stays here. And that now applies to AI processing, too, not just storing files. Which, you know, brings up a really critical question for you listening. If you're using some generic AI tool, where does your data actually end up if it's not explicitly controlled?
Yeah, because most big providers are pretty vague, aren't they? It's often like, oh, it's in one of these 30 countries.
Right, but who's actually checked the data protection rules for all 30 of those places? I mean, realistically.
Exactly. And that immediately hits on trust and control, doesn't it? In this whole digital age, when you put sensitive info into a general AI, who really gets to see it? The black box isn't just how it thinks. It's where your data is, where it's processed, and crucially, what guarantees you actually have. That infrastructure underneath dictates everything. Understanding it is, well, it's vital if you want real control.
All right. Let's peel back another layer then. Let's deconstruct the actual AI stack. What's really powering this privacy-first thing? What we've learned shows it's basically one platform, but it relies on two main API pieces working together. You've got the large language models, the LLMs.
The brains.
Yeah, the stars of the show, right? The bit that understands language, generates text, does all that cool reasoning stuff everyone's talking about. But, and this is the part that often gets missed, the bit that makes it really practical, you also need a vector database. A lot of people just focus on the LLM model.
They do. But for real-world use, with your specific data, that vector DB is absolutely essential. And the reason is, look, LLMs are powerful, no doubt, but they have limits. Even with these huge context windows now, millions of tokens, you can't just shove your entire data set. Like, imagine a Drupal site with 10,000 pages.
Right.
You can't just dump all that into the LLM and expect good answers. Actually, our research shows sometimes with complex private data, bigger context windows can even make the answers worse.
Really?
Worse.
Yeah. And that's exactly where this technique, Retrieval-Augmented Generation, or RAG, comes in. It's kind of the key technology here.
Okay, RAG. So how does that actually work? How does it bridge that gap between my, say, massive internal knowledge base and the LLM? Let's break that down.
Yeah, let's do it. So first step, you take all your content PDF, Slack chats, those Drupal pages, whatever it is, and you feed it to something called an embedding model.
Okay, an embedding model. Right. And what it does is it turns all that text into these multidimensional vectors. Think of it like creating a unique mathematical fingerprint for each piece of content. It plots it in this huge conceptual space where similar ideas end up close together.
Okay, so it's not just indexing keywords, it's indexing the actual meaning.
Exactly that. It's understanding the semantics. Then these number fingerprints, these vectors, they get stored in a vector database.
Got it.
This isn't your standard database. It's specifically built to handle these complex vectors and find similarities between them really, really fast. You do this indexing once, kind of set it up, and then just like, say, Search API in Drupal, if a document gets updated, you just re-index that one piece to keep the knowledge fresh.
Okay, makes sense. So when I, the user, ask my AI application a question, maybe on my company intranet site, my question doesn't go straight to the big LLM brain.
Nope, not first. The application sends your question to the vector database first. And the vector DB uses that vector similarity magic to find the most relevant bits of your data. So instead of overwhelming the LLM with all 10,000 documents,
It narrows it down.
precisely,
Oh.
it might pull out just the 5 or 6 paragraphs or pages that are super relevant to your specific question.
And only those few relevant snippets get sent to the LLM, along with my original question.
Exactly.
Wow, okay, that sounds way more efficient. And I can see how that would lead to more accurate answers, focused answers, and probably help stop the AI making stuff up those hallucinations.
It absolutely does. It grounds the LLM in your actual data.
And the AI application itself manages this whole process. The LLM isn't talking directly to the vector DB.
Correct. The application, like maybe your Drupal site with an AI module, is the orchestrator, pulls from the vector DB, then passes the relevant context and the query to the LLM. The key takeaway here is that RAG basically turns a generalist LLM into a specialist expert on your data instantly without needing expensive retraining and, yeah, with far fewer hallucinations. That's what makes AI genuinely useful for, real business stuff, your private information. And that continuous indexing, like you mentioned with Search API, is vital for any data that changes, keeps it current for the AI.
Okay, so we've got the core tech, LLMs plus vector DBs working together via RAM. But building something that's privacy first and open means these parts need to play nicely with everything else, right? How does the stack make sure it's compatible, that it lives up to that open source promise?
Yeah, good question.
Our analysis found a pretty smart strategy. They basically adopt existing standards. So for the LLMs, the infrastructure mimics the OpenAI API structure. Now, just to be crystal clear, OpenAI itself isn't involved here at all, but by copying their API format...
It means developers don't have to change their code.
Exactly. All those tools people might already be using, things like LangChain, LangGraph, Lam&Index, they just work out of the box. No modifications needed.
And that's huge, right? That interoperability by default means you're not locked into some weird proprietary system. It helps everyone adopt it faster, collaborate more. It's very open source in spirit.
Right.
And then for the vector databases, the strategic choice was PostgreSQL, which, lots of systems use already. And it has great vector support now through extensions like pjvector. tgvector is itself open source. And it basically turns good old PostgreSQL into a really capable vector database, ready to handle all those embeddings we talked about.
So using PostgreSQL, which is already widely adopted, especially outside the Drupal world where MySQL was historically bigger, that just broadens the compatibility again.
Absolutely. It taps into a massive existing ecosystem of tools, knowledge, developers. It's all about leveraging those standards for wider use.
Okay, architecture makes sense, compatibility makes sense. What about the actual AI models, the brains? You got choices there too, right?
Definitely. Broadly speaking, you've got two main camps. You have the open source models, the ones you can download from places like Hugging Face. Think llama models from Meta, or Mistral's open weights models, things like that.
Right, the ones you can run yourself if you have the hardware.
Yeah, and then you have the proprietary models, Anthropic's Claude, the newer Mistral models, OpenAI's GPT series, generally seen as the most powerful but closed source.
But here's something our sources highlighted that I found really interesting, something maybe not everyone knows. You can actually run even those top-tier proprietary models privately.
Yes, this is a key point.
It's a bit of a game changer, isn't it? Companies like Anthropic, the makers of Claude, they let you deploy their models inside major cloud platforms. Think AWS Bedrock, Google, Vertex, Azure, OpenAI. But crucially, within your own private network, your own VPC.
Exactly. It's deployed in your secure slice of the cloud provider's infrastructure.
And once it's running there, the original model vendor, like Anthropic or OpenAI, they no longer have access to the data you send to it.
Correct. Your prompts, your data stay within your controlled environment. This gives you privacy even when using cutting-edge models like, say, Claude 3 Opus or whatever GPT-4 or 5 version is current.
Wow. Okay. So that opens up different ways to actually run these things.
It does. You've got sort of LLM as a service. It's like AWS Bedrock. The cloud provider handles the GPUs, the scaling, everything. You just pay per token, per request. Easy to start, but costs can add up.
Okay.
Then you got GPU as a service. Here, you're essentially renting the raw graphics cards, the powerful GPUs needed to run these models. You install and manage the models yourself.
More control, but sounds more complex.
Definitely more complex and potentially expensive up front. You could be looking at, $10,000 a month or way more for the really high-end GPUs needed for heavy workloads. Plus, you need the expertise in-house to manage scaling, efficiency, budgeting, all that.
So there's a trade-off. Like at some point, if you use a ton of tokens, renting the GPUs becomes cheaper than paying per token.
Exactly. There's a crossover point.
So
But yeah, it comes with that significant operational responsibility. You're managing the metal or virtual metal yourself. It's a big decision cost versus control versus operational burden.
Okay, let's bring this back home to the core promise we started with. Privacy and data protection. How does this multi-regional setup actually deliver on that? The fundamental promise, as we understand it, is you choose the country. Switzerland, Germany, US East, US West, UK, Australia. Wherever you need your AI data processed and stored. And here's the absolute key part, the non-negotiable. There is no global load balancer routing your data around.
No central point for data flow.
Instead, it's like they've built a completely separate, independent infrastructure for each country or region. You have to imagine 25 parallel self-contained setups, each one with its own LLM proxy, its own vector DB proxy, its own connections to LLM providers or GPUs, its own post-RESTful.
It's a significant engineering effort.
Oh, I bet. That sounds way more complex and probably costly than just having one big global system where data goes wherever is cheapest or fastest, right?
Wow.
But that isolation is what actually guarantees the data stays put. True data sovereignty.
Precisely. It's physical isolation and local control. That's the insight.
Yeah.
Turning that global challenge into genuinely localized solutions. Now, there is a central control plane, a UI or API, where you manage your account, create your API keys for, say, the German region or the US region.
Okay.
But, and this is crucial, when your actual AI tool, like your Drupal site, makes the request using that key, it talks directly to the endpoint for that specific region. The data doesn't flow through a central point.
Got it. So the control plane is for management, but the data path is strictly regional.
Exactly. And connecting that to the bigger picture, it gives you that granular control over where your data lives, which is absolutely essential for compliance in many industries. Finance, healthcare, government.
Yeah, makes sense.
And this flexibility goes further. You can run this setup in their shared cloud, or you can deploy it into your own cloud account, your AWS, your Azure, your Google Cloud, or even, get this, run it on-premise in your own data center.
Really? On-prem?
Yeah, as long as you've got Kubernetes set up, which is pretty standard for managing containerized applications these days, you can run the whole stack yourself.
Wow.
And that even allows for hybrid approaches. Maybe run your baseline stuff on-prem for maximum security, but then burst out to cloud GPUs when you have peak demand. The APIs remain the same.
That's incredibly flexible, and it seems easy to get started, too. You mentioned the Drupal AI provider. You can literally sign up from within Drupal, pick a region like US, get a 30-day trial, no credit card needed.
Yep, designed to be super simple to try out.
And you can see real-world uses immediately. Like, imagine an editor writing a press release. The AI could automatically check it against company style guides, maybe correcting Amazio to Amazee.io with a lowercase a, or suggesting replacing informal words like guys with folks. And even give a little summary of the changes it made.
Yeah, that's practical AI helping with compliance and brand voice right there, tailored to your rules. Okay, now let's hit what might be the biggest privacy concern people have with AI data logging. What happens to my prompts and the AI's answers? What we found suggests this infrastructure takes a really strong stance here. The quote was basically, "We store the absolute minimum we really need." So what does that actually mean for you?
What don't they store?
Well, let's start with what they do store. It's only metadata. Things like which API key was used, the timestamp, how many input and output tokens were processed, which AI model was used like Claude or GPT-4, the user's IP address, and the calculated cost for billing. That's it.
Okay, so just operational data.
Exactly. Now, here's the critical part, the big privacy win. What they do not store are the actual prompts, the questions or text you send in, and they do not store the responses the AI generates.
Nothing of the actual content. Zero content. So what does this mean for you listening? It means the company operating this infrastructure can't become a giant honeypot for hackers because there's no sensitive user conversation data to steal.
Reduces the risks significantly.
Yeah, right. And your data is protected if the company changes hands or policies down the line. And really importantly, your data is not being used to train their AI models.
That's a huge differentiator.
Yeah. Apparently, when you look at your usage dashboard, you just see the metadata counts, costs, times. There's absolutely no way for them, or through the dash, to see the actual content of what was asked or answered.
And that stands in pretty stark contrast to a lot of other AI services out there, right?
Mm-hmm.
Many of them explicitly state they do store your prompts and responses, often for improving their models, sometimes for who knows what else. And getting it deleted can be tricky. It really brings up that question again. Who truly owns your data's life cycle when you use these tools? This approach, combined with the open source nature where you can actually check the code, that transparency builds a lot of trust. It puts the control firmly back with the user.
Looking forward now, what's next? Our sources indicate customers are already pushing for even more advanced privacy stuff. What's on the horizon?
Well, one interesting area is analytics without logging the actual data.
Yeah.
How can you give users insights into how AI is being used? Like what kinds of questions are people asking? What features are popular without storing the sensitive prompts?
Yeah, how do you do that?
It might involve things like using cryptographic hashing on the prompts before analyzing patterns, or maybe using separate privacy-preserving AI models just to summarize usage themes anonymously. It's an active area of research.
Okay, interesting. What else?
The other really big one, the really cutting-edge thing, is secure enclaves, or sometimes called confidential compute.
Ah, I've heard of that. Sounds complex.
It is pretty cool technology. The idea is this. Your prompt, your question, gets encrypted on your computer before it's even sent.
Okay.
It then travels across the entire network through all the infrastructure, completely encrypted. It only gets decrypted inside the secure memory of the physical GPU chip that's going to process it.
Inside the chip itself.
Right inside the silicon. The GPU does its work, generates the response, immediately re-encrypts the response, and sends it back to you, still encrypted. You decrypt it on your end.
Wow. So the raw data is basically never exposed in transit or even in the main system memory, only momentarily inside the protected part of the GPU.
Exactly. The implication is massive.
Yeah.
The only way someone could theoretically access the raw data would be to physically compromise the GPU chip while it's actively processing your request, which is incredibly difficult.
Yeah, sounds like it.
This is seen as the gold standard, the most secure approach, really suitable for ultra-sensitive data, think government secrets, classified healthcare research, that kind of thing.
That's pushing the boundaries for sure.
It really is.
Yeah.
And it encourages that critical thinking about how far we can and should go to protect data in the AI age. There's also talk about fine-tuned models tailored specifically for one customer's needs, though that's often pretty expensive and maybe overkill for many use cases.
What about things like environmental impact?
Yeah, good point. While this infrastructure provider doesn't own the physical data centers, they can get data from their cloud partners, AWS, Google, Azure, about the energy consumption. So they can report kilowatt hours used, estimate CO2 emissions associated with your AI usage.
So you could potentially track your AI carbon footprint.
Potentially, yes.
Yeah.
And you can even choose to run your workloads in regions known for greener energy sources, like maybe hydropower in Switzerland, although that might come at a premium cost. It gives you options.
And ethics, like preventing misuse.
Well, since they don't log the private data content, they can't really police that. But standard public content policies still apply. You can't use it for illegal activities, hate speech, etc. that violates the terms of service. The technical ability to add content classifiers exists, like checking for harmful content, but whether that gets implemented widely probably depends on future regulations and demand.
Okay, let's talk about the open source angle again.
Well.
You said earlier the code is out there.
Yep. Our sources strongly emphasize this. Like, you could literally download the code that runs this whole proxy and database system and theoretically start your own AI hosting company tomorrow.
For real.
For real. Apparently, other companies are already using components developed by the same team, like their hosting platform Lagoon, to build their own services. But they make a key distinction.
Which is?
The code might be the easy part, relatively speaking. The really hard part is running it reliably, 24/7, globally, with on-call teams ready to fix things across like 18 different time zones. That operational expertise is tough to replicate.
Yeah, I can imagine. Operations are always the challenge. Now, another big pain point for people using AI, the pricing. It's usually per token, right? And that can get confusing.
Oh, yeah. Confusing and stressful. Our sources called it token cost anxiety.
Token cost anxiety. I like that. Because you hit send on a complex request, Or maybe a chatbot goes wild, generating 500 slightly different answers for one user.
And suddenly your bill explodes.
Yeah.
You're constantly worried about how much each interaction is costing.
Exactly. No more holding your breath. So what's the solution here?
Their approach is pretty clever. A fixed monthly price. For the Drupal AI provider example, it's something like $30 a month, flat rate. That completely removes the token anxiety.
$30 a month, regardless of how many tokens you use, within reason.
Within reason, yeah.
Yeah.
It's based on aggregated usage across lots of customers so they can average it out. They even shared a story about someone on a trial who somehow burned through like $700 worth of tokens in 2 hours.
Whoa. What happened? Did they get a massive bill?
Nope. Apparently, they just got a polite email asking, hey, what are you trying to do? Maybe we can help optimize. Not a surprise invoice. That really shows a customer-focused approach, building trust.
That's refreshing.
Yeah, and that transparent pricing, just like the open source code, it all ties back to building trust and predictability. Internally, behind the scenes, they are tracking token usage. And they're dynamically shifting workloads between the cheaper pay-per-token LLM services and their own rented GPUs based on real-time demand, constantly optimizing their costs. But the customer just sees that nice, predictable flat rate.
Clever. So they manage the complexity, you get simplicity.
Pretty much. And it also loops back to performance. Choosing the right region isn't just for data laws, it's for speed. If you're in the US and you pick the Australian endpoint for your AI calls.
It's going to be slower.
Yeah, latency matters. Local execution is faster. Simple physics.
What a journey, seriously. We started with AI feeling like this impenetrable black box, and now, hopefully, you feel like you've had a real deep dive inside. We looked at why this kind of privacy-first infrastructure is needed, how it uses things like vector databases and RG, why open standards matter, and how they meticulously designed it to keep your data locked down in the region you choose. So, what does all this mean for you, listening? It means there's a clear path now, a way to use powerful AI without giving up control over where your data goes or sacrificing its privacy. You can get this knowledge quickly, see real examples, and even get a peek at what's coming next in secure AI.
Yeah, and it leaves us with a really important question to think about, doesn't it? As AI gets woven deeper into everything we do, personally and professionally, how much control over our own data are we actually willing to give up? And maybe more importantly, what's the responsibility of the companies building these AI systems? Should they be building systems like this one that empower us with choice and transparency? Or will they continue to make those choices for us, often hidden away in the terms and conditions? It's definitely something to keep thinking critically about. Where does my data go, and what guarantees do I truly have, especially in this new AI era?
That is a wrap on today's Drupal brief. Remember, this was an AI-generated summary, so be sure to check out the original source for the full story and all the details. Before you go, if what you heard today got you excited about trying something new in Drupal, remember that Drupal Forge has you covered. Whether you want to test that new module, demo a concept to your team, or just explore the latest Drupal features, you're literally 5 seconds away from a fully loaded development environment. No downloads, no setup, no hassle. Just pure Drupal innovation at your fingertips. If this episode was helpful, please hit that subscribe button and leave us a review. It really helps other Drupal developers discover the show. Thanks for listening, and we'll catch you on the next Drupal Brief.